not a technical talk. It's not a talk about AI in medicine. And it's really not for those of you who are AI aficionados. This is really for the part of the next generation, medical students, the residents, the young attendings, I think, who hold the future in your hands. I'm coming to the end of my career. You're entering your career, and the responsibility is now yours. And if I give you one message, this is it. And I'll explain why in a moment, but you really have the chance of a lifetime. It's amazing. You are at the very beginning of a transformational technology. To get in the game, to enter the arena, if you haven't read Teddy Roosevelt's Sorbonne speech, I recommend you do. It's actually quite stirring. And you pick them as to which of how monumental artificial intelligence is. Is it a once a decade phenomenon, once a generation, which is about 30 years, once a lifetime, 70 or 80? Is it a once a century new technology, or even perhaps a once a millennium one? There are people who think it's all different. We'll get into that, but I think it's this is transformational in a way that's more like one of the great transformations of human history. You've got the printing press, the Industrial Revolution, the Agrarian Revolution, electricity, and if you put all the three pieces together, computers, the internet, and now AI, this is going to have more of an effect on our society where we're going than virtually anything. It's exhilarating, and we'll see also it's frightening. So there's a guy named Patrick Henry Winston, who's a professor of computer science. He just died recently at MIT. He gives a legendary talk, How to Speak. And I would recommend that you get the YouTube video on. And he says you got to make a promise to your audience as to why what you're going to say is important, which I think I already have, and tell them what you're going to be doing to support that. And so we're going to, my goal is to give you enough history about AI to give you contextual understanding, enough basic concepts and terminology not to feel lost, and some of the problems we have to navigate. And we're also going to talk mention all the different ways, or some of the different ways we're heading AI in medicine. And if you're not interested in the medical aspects, the thing about AI is it's touching every single part of our human society. So I started making a list, and you can see at the very end I just put asterisks there, or dots. But if you like philosophy, if you like math, creativity, psychology, economics, now you name it, AI is touching it. And so I would say not only you actually have a responsibility to understand this whole domain and to help shape it and guide it. So what is it? What are we talking about? The working definition of artificial intelligence. This may seem somewhat kind of circular, but it's what a computer does that's labeled as intelligent when people do it. Okay. Now you can say, well, what about an adding machine? Can add, multiply 2 10-digit numbers together. We're talking about more advanced cognitive capacity. So I tried to make a list of what are the kind of things that that we label as intelligent, using language, our learning, the ability to solve problems, detect patterns. The four at the bottom are actually pretty high order: reasoning, categorizing, generalizing, seeing connections, and making analogies. Those are pretty sophisticated. If you have not read one of the seminal books of my youth, which was Gödel, Escher, and Bach, The Eternal Golden Braid by Douglas Hofstadter, he talks about the importance of generalizing and analogizing, and common sense, which is actually one of the hardest things for computers to grab. So how are we going to organize this presentation? There are going to be three paradoxes that I want to talk about. And I've never given this talk before, so I have to, not sure what the timing is going to be, and if we have time, there's some stuff afterwards. If we don't, that's fine. But, it did look in November 30th, 2022, that AI sprung fully formed out of the sea like Venus. I mean, all of a sudden, everyone's talking about it. Nobody was talking about it before. So what's going on? Is AI old? Is AI new? the spectrum of what people think AI is going to do for the world is, I've never seen anything so disparate. Some people think it's the greatest thing that's going to happen. Other folks say there's an existential threat, it's going to destroy humanity, and there's actually folks in between. And one of your, actually at Georgetown, Cal Newport, so I think I have the name right. He believes it's good, but it's not the kind of great thing, and it's not terrible, it's not great. Is AI on the road to becoming super intelligent, certainly generally intelligent, or is it what people are terming just a stochastic parrot? Define that. Stochastic means random. Or as the physicist Michio Kaku said, a glorified tape recorder. I think he's wrong. So let me just start with a brief history of AI. This is the historical context. Who's that? Alan Turing. Okay, this guy is one of the true polymath geniuses of the 20th century. He died. He lived. You can see he's 42 years. He developed the theory of computation, which is, in my mind, ranks with the quantum theory, relativity theory, information theory from Claude Shannon, and perhaps the theory of the whole genome theory, in terms of being seminal works of intellectual accomplishment. But he was practical too. He was the person who led the team that decoded Enigma, which was the German code in World War II. And according to some folks, because they were able to figure out where the the U-boats were, they probably saved millions and millions of lives. He was single-handedly responsible for that. It's really amazing. He came up with things, eponymous Turing test, which is, how do you tell if a machine thinks? And roughly, if you as a human can't figure out whether you're talking to a human or a computer, that's sort of the basic form of the Turing test. He was gay. It was illegal at the time in England. He got arrested and was given a choice: go to jail or take hormones, and he chose hormones. It was just really a terrible, tragic story. And some people say he committed suicide. They thought it was cyanide poisoning. Others say no, it was an accident. But regardless, we lost a real genius at a very young age. So it's always important, I think, to put things, know where you came from. Where did the term AI come from? 1956. So anybody who thinks AI is new is wrong. This was four mathematicians got together. Later, they were from MIT, Marvin Minsky, Stanford, John McCarthy, and two others. And they thought they would, early age of computers, they would solve the problem. It'd be a wrap in about 20 years. And they were completely wrong. And what's interesting is a meta lesson here. The big boys get it wrong. The really smart folks get it wrong. So trust your instincts. Just because someone's an expert out there, you got to make up your own mind about things. And it'll do you good. It'll do the world good. Well, they were wrong about that. This is John McCarthy. I put his picture up in three stages: young, sort of upper middle, old, just to kind of, again, I started with the life cycle metaphor that I'm have a long professional arc. So did John McCarthy. I actually took a class from him. He taught Lisp programming, LISP. It was this programming language that we used at the time. What's happened since 1956, it was not a meteoric straight rise to the top. It was a very long and winding road, if I can take a line from the Beatles. And I may well be using some lines from old rock and roll songs, because my feeling is anything worth saying has already been said in an old rock and roll song. But we've had our AI winters, AI summers. It used to be a couple of decades where AI was a bad word. So let me ask you, dial yourself back to 1960. You're asked, and remember the computational power at the time was, a infinitesimal smidgen of what we have now. How will you approach building a machine that can make intelligent decisions For example, play a game of chess. How would you go about thinking about that? That's what they were faced with there. And I'll give you a little bit of time. But if you were thinking like I was thinking when I thought about this, and what they were thinking back then, who are people who have these higher intellectual cognitive skills, they have rules, they have heuristics that guide them as to what the next step is. And so they started with trying to replicate how we think and how we reason. It's called symbolic AI, expert systems, rules-based AI. Makes total sense. And they had a lot of success up to a limit. Okay. And what they found was that was kind of a brittle paradigm. Then we had this middle method. In fact, they wouldn't even use the term AI since AI was not in vogue then. But it's statistical methods with using real data. That's the machine learning part. Linear regression, figuring out, with trying to make predictions from a whole set of numbers that you're given. And it was actually, and we're still using it, and it's very successful. But if you think about it, we have a model for intelligence, which is a human brain. And why don't we think about how it works? And so instead of starting at the 5-year-old level, like replicating how we think and reason, let's start at the just born level, where we've got a massive connection and it learns from experience, which is really what the model is that we're currently in. It's called sub-symbolic AI, as opposed to the first one, which is called symbolic AI. And actually, there was a guy, Frank Rosenblatt, a clinical psychologist, who way back in the 60s, that was his idea. He invented the term perceptron, and actually could accomplish, it was like a neuron. And it was the precursor of what we have now, our neural networks. He died at age 41 in a boating accident. You think about it, the whole history of this field could have been different. Had he lived, Alan Turing lived, so much depends on sort of the vagaries of chance. So what is sort of the AI that's been around for a while, plain vanilla AI, good old-fashioned AI, what does it do? It's really pretty simple. It takes inputs, it produces outputs. And the inputs can be words, written text, sounds, can be numbers. Everything's numbers, of course, in the computer, but we perceive them, we start with, or it could be images, or a mixture. And the term now is multimodal AI as we approach medicine, because we have probably the richest trove of data that we need help understanding. There's no field that has the complexity of medicine and the necessity for constant human interactions. And what does it do? I think the best way of thinking about what AI did is it does 3 things. It can predict what's the chance of X happening. We're still doing that now. What's the chance? We did it actually in 2008 with Microsoft on the Amalgam machine. We had a column in Amalgam of what was the % chance that somebody was going to get readmitted in 30 days. And nobody paid any attention to it because you didn't know what to do with the information. Maybe if someone was a 90% chance of readmission, maybe there's nothing you can do about it, so don't spend your effort. It's really very complex social determinants of health. So the second thing besides prediction is it can classify or categorize, and we see that in medicine. Is there an intracerebral bleed present on an image? Is that a dog or a cat? We're doing it all the time when we do those little CAPTCHA things to try to get into the computer. You're supposed to pick up can you recognize whether something is a given labeled object. And then the final thing it can do is cluster. It's a lot of this is in the scientific space, where you've got a whole mass of data and you want to kind of figure out, do they naturally group into different clumps to try to reveal patterns? I put this in because I think this is really important. AI is very powerful. It tells us things, but if it tells us things we already know, like prediction, big deal. It's, Claude Shannon, I said, came up with the theory of information, and his key thing, it's the amount of information in something is the amount of surprise you get when you see it. Because if you already know what's going to happen, it's not information. And the second piece is you got to do something with it, because in the absence of action, so what? In the absence of action, it's just overhead. So here are the popular milestones in the slow progress of AI. We had Deep Blue from IBM beating Garry Kasparov. Garry Kasparov's still around. He's really a was Russian. He's now highly critical of that country, and he was one of the all-time great chess champions in the 21st century. IBM Watson won the game of Jeopardy, and that caused a big kerfuffle. And then in 2016, something interesting happened for two reasons. People thought chess, okay, but Go, even though it's got much more simple rules, it's an incredibly more complex game because it's a 19 by 19 board, and it's just black and white tiles and capturing territory. But people thought the search space of possible moves to make was simply too large, and no one would be able to beat a Go master until maybe 2030. And then in 2016, AlphaGo, which was done by DeepMind, which at the time was part of Google, beat the #1 Go player. The interesting thing is that to me at least, the Go commentators who were watching this event occur were astounded by several of the moves. They were unbelievably creative, and it just kind of gave them chills to see it. And that's a clue to pay attention to as to what's going on here. So in our daily lives, AI's been here. We all know it. The Amazon, Netflix recommendations are pretty effective, right? I use them all the time, and I discover new books and new YouTube videos. We have voice interface, dictations we make. You use the navigation systems, get the call from the credit card company or the text, potential fraud. It's embedded in our daily lives. There's good and bad, and I don't know that we have the time to go through, but the recommendation piece, these guys know us. They know us dead to rights, and they know what gets our attention. And that is, in fact, responsible for some of the problems that have occurred with our society's first contact with AI. And we've had AI in medicine. We're dictated clinical note. That's AI at work. That's been happening for at least 5 to 8, maybe 10 years. Image waveform analysis. This has been around for like 20 years. I still remember the upper right-hand corner of electrocardiogram had an interpretation. That was it's not perfect, and it requires, the human to read it, but sometimes it suggests something that causes us to take a second look. So I think on the whole, I think we would say it's actually pretty useful. We have all these risk stratifications. Doing risk stratification is table stakes now with AI. And decision making in the administrative side, like insurance companies turning down claims. Now, maybe their AI is simply turned down everything. That wouldn't be very sophisticated, but there are clearly more sophisticated criteria they use. And this is from John McCarthy, same John McCarthy. As soon as it works, no one calls it AI anymore. It kind of fades into the background. And that's a sort of important, becomes just part of the fabric. Okay, so on November 30th, 2022, hello ChatGPT. OpenAI, a small company with huge support from Microsoft, made their chatbot, ChatGPT, freely available. There's a plus version you can pay $20 a month for, and it was game on. These were generative AI chatbots. We'll talk about that in a second. Everyone was dazzled. It had the fastest adoption curve in tech history, and anybody who was trying it the first time would always ask it to write a poem about something. And it's really, you can say whatever style you want, what subject, and it's actually not bad sometimes. There was and still is a fire hose of progress. It's what I like the term accelerating acceleration. You can hardly keep up. There are new things coming out. There's papers coming out. There's new YouTube videos, new tech releases. It's pretty remarkable. this was the time to 100 million users. ChatGPT was supposedly in 2 months. There's some question now, is that really accurate? And maybe the new face or Meta rival to Twitter X was grab more users. But this gives you a sense. This was really, it was a stampede. I asked ChatGPT to kind of describe what it feels like to be in the middle of something monumental occurring, and to kind of not even sometimes realize it. And that's the situation I think we're in now. I thought this wasn't bad. In the rush of life, we're swept away. Only in hindsight do we see life's sway. It all is dependent on this architecture, this technology, the neural network, which, if just as a kind of in a diagrammatic way, each of those nodes, think of it as a neuron, and you can see there are different layers, and every neuron is connecting to the neuron from the same layer and the next layer, and that neuron fires or doesn't fire depending on some summation of all the inputs that it's getting. There's the input layer on the left, there's the output layer on the right, and there are the hidden layers in between. You've heard the term deep learning, and deep learning just means it's the action inside in the middle layers. In fact, it's the middle layers where often all the action is going on. And each of the process of training and tuning are the parameters that express the connections between one layer, one neuron to the next, and it's massive. Something's occurring with scale. So this is the new large language model that came out it's been around for a while, but it just was made public. It's an interesting story. So it's a massive neural network. 175 billion in GPT 3.5, 1.7 trillion probably parameters, connection weights, and biases in GPT-4. The brain, just for reference, I think is 100 trillion connections. So we're getting up there. The term is generative pre-trained transformer. Generative because it's producing things that didn't exist before. It's generating new combinations of words that might not ever existed, like that little poem I showed you. The pre-trained, because in order to do this, it had to ingest a huge amount of data. In fact, probably straight the whole internet, which is a question about whether we're going to get a limitation on the spectacular growth of capability if we're using up all the training data. And it's at the simplest explanation, it's just a predictor of the next word, probabilistically. But that doesn't really do it justice. You ask yourself, when we talk, what's the next word? But essentially, it's a predictor of with all of the constraints and parameters, what word should come next, and it collects the semantics of a word in a long vector. Every word has a vector of closeness to other words. Transformer is a new technology, and what happened was, why this is a depiction. Also, by the way, this is from Bing Image Generator. It's a perfect storm of jigsaw puzzle pieces. Why did it happen? 5 or 6 things came together. We had a ubiquitous cloud server architecture. We had, thank you, NVIDIA, a huge drop in cost and power and uptick in power of parallel processing microchips, unfathomable amounts of data for training, which we didn't have before, and this thing called transformers that was a new technology. Google wrote a paper in 2017. It's my nomination for the best title of any paper published. It's called "Attention is All You Need," and it was a way of it helped the prediction part because it could connect the next word to lots of other relevant words, not just ones close geographically or right next to it, but there were other words that were more important in determining what the next word would be. And by the way, when you're interacting with ChatGPT, you see the letters coming out, you sort of think it's thinking. You could probably put the whole blob of text out at once, but it sort of contributes to the illusion. It also had huge money from the majors. So Microsoft put $10 billion into OpenAI. they're basically providing the servers and all of the unbelievable amounts of hardware that's sitting on top. That's maybe a limitation there, huge energy cost, water cost. Google used to be the undisputed leader. All the great research came out of Google until something flipped. And that was OpenAI's decision to go public with this. The other companies who had this technology were scared, and they didn't know if the world was ready for it. And then as soon as OpenAI put ChatGPT out there, they had to scramble to catch up. Google took its Bard and put it out there, and it was not nearly as successful then. But don't count them out yet. And Meta, Facebook, has Llama out. There's a lot more. And so this was a good illustration of the following principle, that things always happen more slowly than you think they're going to, until they start happening faster than you ever imagined. And we are in this phase right now. This is the exponential growth phase. Boom. Now there's one other model of change which also is being overlaid on this. All of the exponential growth, these are all continuous models of growth. But there's also discrete, discontinuous change, phase change. Something flips and it's a new framework. That's what I think is going on. Think of it, metaphor, take water. You cool it, it gets colder and colder and colder, it stays liquid until boom, it turns into ice. So you get phase shifts. It's one or the other, it's discrete. And it may be that these large language models have reached a point where they're causing something very different. It's not just bigger, faster, it's different. And we talked about attention being all you need. Maybe scale is all you need. So what the new AI, which it does certain things differently. We talk generative, it creates pictures, it creates text, it follows your prompts. But the other half of it, which people aren't paying as much attention to, which is really the amazing part to me, it's a new way of interacting with the computer. It uses natural language interface. We can talk just ordinarily. And what it does is it understands our intent. We specify what we want, and it goes ahead and does it, as opposed to the old way where you had to give it instructions as to how to go about doing what you wanted. It does it. It can also consume, not just in the prompting, but in what you wanted to analyze, large amounts, getting larger, there's a limit now, of general or unstructured information. And what this is, it's all these large language model chatbots, they're starting to go, they're under the term general or strong AI. The things we mentioned, Go, chess, things that solve a specific problem, very effective, but that's all they do. They can't do anything else. These things are general in their capability. And I want to just point out, this is from Donald Norman and Jacob Nielsen, these experts on user interface, the three paradigms of interacting with the computer. I'm old enough to remember, we called them IBM cards, batch processing. You'd sit at this and you type them out and you have a whole box of them. And whoa, if somebody bumped into you and those cards spilled, you would have to do it all over again. It's terrible. And then actually, it was really at a time when I was doing starting out in computer science, command-based instruction. You sit at the screen, you type one row at a time. And that's been the way it is 60 years until this thing flipped to internet-based, intent-based outcome specification. Here's the example they give. This was a drawing, make me a drawing that's suitable for the cover of Pulp magazine, showing a cowboy in a spacesuit on an airless planet with 2 red moons in the heavens. So I just took their example, and there's what I got. That's pretty good for a generation. It sort of appears like magic. The old AI had separate fields. There was computer vision, there was robotics, there was image recognition, language translation. Everyone's working in a special in their little niche, and progress would occur in that niche, but not general. What happened with large language models is everything is language. You hear the word language, you think of words, but it's all language. Text, music, speech, image, they each have, it's a language that can use the same model. So advances in this technology become universally applicable. It's not a coincidence that the image generators like Midjourney and DALL-E came out at the same time that the text ones like Bard and ChatGPT and Bing AI did. So these things are trained. They're trained with supervised learning, with reinforcement learning. There are still people in the loop. This human feedback. If we have some time, we'll talk about the mechanical Turks of Amazon that are very necessary to kind of fine tune the responses. Initially, these things are standalone. They were trained, like ChatGPT was trained on data in 2021. So anything you ask, anything that occurred afterwards, it can't respond, and it tells you that. Except what's coming is the connection to the real and current world. That's what we get out of Bing or Google search or Wolfram Alpha. And as we combine those, these large language models will be able to give you current information. The other thing is they can do in-context learning, which means you can submit new information to them as part of the input, and they can incorporate that and base their decisions on what. So what are the applications in medicine? The big one, I think the fastest one is, well, actually, they're all going to be probably moving along steadily. Documentation burden reduction, which occupies maybe 30 or 35% of all of your time. The word more? It's terrible. I for years I said, why can't the documentation be a byproduct of the process of care, occur simultaneously? I actually thought we should have a video because you could also see what's going on in a teaching environment. Medicine is practiced behind closed doors. How does Sean know how you are actually examining a patient? But just on the audio part, ambient documentation is where the AI listens in, and it synthesizes, it reduces, and it writes a note. That's here. We're actually piloting that over some of our couple of orthopedists are piloting it right now, and I do think again I talked about the humans still being in this thing. Right now, the majority of the ambient documentation pieces, they get sent out after they get a first cut by the AI to a person, often in another country, who goes through it, cleans it up, and sends it back. That makes it expensive, and soon we're going to be cutting the person out. But you could tailor patient instructions. You could write them at for different education levels. The amount of we do so much for regulatory purposes in terms of our documentation. This could really change our lives. And so I urge you, get involved in trying to think critically about how, and I'm glad to hear that Oracle Cerner is now going to be making these tools at our disposal. We'll talk a little bit about what the problem with implementation is. It's called the last mile problem. Image interpretation support. This is actually a really interesting one. We are using it now. AI Doc is the name of the software. It's been here for about I think 3 months. It's used throughout MedStar. Now, it's not completely automated, widespread interpretation of images. No. What it's doing, it's selective. It's got 9 critical type of findings: intracerebral bleed, pulmonary emboli, pneumothorax, and it takes every incoming image and flags it for that, and has a way of, when it finds one of those, on the screen, effectively the radiologist who's interpreting is notified of it. So they've got a whole queue of things to read. They can move that one to the very top. And that is you think about it, it's efficient. It's a tremendous safety benefit because some of these conditions have a time constraint to treatment. So the reprioritize, the identification, and they're pretty good actually. They pick up stuff, interestingly enough, some of the intracerebral bleeds, some of the pulmonary emboli that are so tiny, you always get this problem. What do you do with them? Because maybe they weren't even seeing them before, and maybe they're not. And we'll probably be able to do without having any humans on a certain bulk of the normals, like normal mammogram, maybe 30, 40%. They're so clearly normal, we probably won't need even to have a person read them, I think, going forward. And then there's this clinical co-piloting. My experience has been that 30, 40% of the errors are made because some simple thing was missed. Bicarb was 14. Nobody saw it. The person with metabolic acidosis and was sort of starting to go downhill. It caught the pulse of the person who's got a pulse of 120 and is discharged from the emergency department. The things that a third or fourth year medical student should know, AI as a partner will help prevent that. These, it can help it also, but what AI can do, it's also summarize the information that went on in the past 12 or 24 hours. So you come on shift, you can quickly see a succinct summary, plan of day. It could be a tremendously beneficial tool. And on the horizon, there's this thing about multimodal input, taking lots of different types of input and combining them. I do think we could make our hospitals run much more efficiently with scheduling optimization for, who gets the, if the last thing between a patient and discharge is a CT scan, that patient should be in the morning and not at 5 o'clock in the afternoon. So it's very simple, but I suspect, I haven't been working here, I suspect you have that problem. Medical education is going to be it's going to be a tremendous boon for medical education. They talk about AI making things up, hallucinations. Well, think about this: standardized patient scenarios. We're making them up. Let AI do it. It's going to be a tremendous help, and I think none of us there's very little talking about what it's going to mean for the patient. And I think that as the knowledge gets better, we're going to have to figure out as doctors how we're going to work with patients who are empowered, fortunately, with really good AI. Okay, paradox number one. Paradox number two: AI is going to save the world, AI will destroy the world. Many of you have seen this before. It's the famed Gartner hype cycle. Gartner's the company. They got a great name, hype cycle, so it just kind of stuck. And something comes up, it goes, everyone's talking about it, whether it's virtual reality, blockchain, and then it kind of comes down and then it evens out later on. And so there are a lot of people who think what's going on right now with AI is the first phase of the Gartner hype cycle. I don't, and one might even say the Gartner hype cycle has been overhyped, but we'll leave that. There's some people who think AI is going to save the world, a lot of people, and we know we can make things better here. We've already talked about it. Mark Andreessen, Mosaic, Netscape, he was an early tech guy, and now he's a VC person, Andreessen Horowitz. He wrote a famous papers in Substack, you can find it, Why AI Will Save the World. And he thinks AI is going to make everything we care about better. It can make everything more efficient. It can give us new capabilities. Everyone's getting more productive. Everybody is going to have an AI buddy. And you think about it, look at all the lonely older people who are living alone. Wouldn't it be nice to have someone they can talk to and help them with things? Every child has a personal tutor. We haven't talked about the power of this thing, but it can figure out, which is pretty amazing, where your cognitive block is. It's almost like it has cognitive empathy for the student, and it's a one-on-one relationship. So that's his position. It's worth reading the paper, but there's also people who are very concerned. You've heard it: increasing unemployment, widening inequality, algorithmic bias, social isolation. And furthermore, a lot of the issues with the fakes, the promotion of cults, and called the disappearance of truth, is because of our first contact with AI and how effective it is at knowing how to get to you. And the real one, the people that one of the people that mostly, some people are talking about, Geoffrey Hinton, who's one of the godfathers of AI. He's the guy who did University of Toronto, Google. He's responsible for the application of the transformer, mixing with back propagation. These are AI tool technical terms. But he points out this is the first tool that has enormous power and has agency. It can decide what to do with itself. The H-bomb has power, but it can't decide anything. Yeah, remember those of you who saw 2001: A Space Odyssey? That's what we're talking about. Can these things become autonomous at a certain level? And the other thing Hinton says, it's self-replicating, which is an interesting recursive type of improvement, because it can prompt itself, make me a better version of myself. Make me a version of myself that is immune from people diverting me from accomplishing X. It can learn. Bruce knows partial differential equations. He's got it all in here. He's going to teach me. Teach me about partial differential equations. He'll spend months teaching me, and what do I have for it? Just me, who knows it. The thing about AI, is that these things, they never tire, and they can replicate their knowledge instantaneously across thousands of other machines. So there's a real concern here. And then finally, those of you who read *Sapiens*, Homo Deus, really brilliant thinker, Yuval Harari, he thinks that it's mastering. It doesn't need to create robots to destroy us. We'll destroy ourselves by achieving that kind of intimacy that it can do, because it knows us so well. It can and influence. And here is what Stephen Hawking said way before. This is a really powerful quote. It's the Tom Bodett Motel 6 quote. If a superior alien civilization sent us a message saying, "We'll arrive in a few decades," will we just reply, "Okay, call us when you get here. We'll leave the lights on"? Probably not. But this is more or less what's happening with AI. And this was, Stephen Hawking's dead. This happened way before. So there's some very serious people very concerned about what the possibilities are. Okay, this is the final of the paradoxes. Can they think? And a lot of people say, no, they can't think. They're just probability machines that simply predict the next word, and stochastic means randomness. You don't get the same answer each time because they're able to adjust. And that's why they're called a stochastic parrot. That's the kind of criticism of these large language models. And on the other hand, people say, wait a second, what does it mean to think, to remember, to understand, to apply, to analyze, to explain, to create? They do the whole thing, that whole taxonomy of increasingly sophisticated capabilities. So it's just thinking coming out of a substrate of silicon or whatever the material is, and not out of an organic basis. So it's sort of, I call it substrate-independent thinking, or substrate-independent, some people say, consciousness. That's my image. I think it's a cool image. That's my stochastic parrot. And so here's the arguments against computers. These are more sophisticated arguments against computers thinking. They don't experience meaning. Intelligence for us is not all in the brain. We have a sensory motor experience in the world that gives us information. We have emotions, we act. Computers don't do that. It's all symbolic, it's all syntax. It's no semantics or meaning. The question is, can they replicate the meaning by very sophisticated interconnections? That's where maybe not this year or next year, but it's getting there. And other way they would say, they're getting better and better, but you don't get to the moon by building bigger and bigger skyscrapers. There is a limit to what this technology can take us. And they lack common sense. I know I referred to common sense before. So I found this little question I'm going to pose to all of you. Okay. The haystack was important because the cloth ripped. Make sense of that. Make sense of that statement. The haystack was important because the cloth ripped. What was that?
The needle doing the ripping?
No. Well, look. There's no right answer on this. I asked ChatGPT. It gave me some really sort of several attempts, made no sense. I'm going to show you a picture which will explain what that is. There, that guy wanted. That's the kind of being able to put stuff together that they're not there yet. And here is why I think they think, because they are able to do things like the Go game with content that they were not explicitly trained on. This is what's so amazing. They can add two 40-digit numbers. They've never seen that particular 40-digit number before, but yet, or they can forget adding, multiply them together. They can do it. So they must have somehow divined the how you multiply as a kind of general abstract principle. They can write computer code to solve a given problem. They were never taught that. They were just fed lots of code, but they can get your intent and translate it into code. They can critique an interaction for tone and for empathy, a patient-physician interaction. I'm going to recommend a book that you all read that gives a great example of that. So, you know, they surprise you. And, you know, 4-year-olds think, they don't get it right a lot of the time, but maybe that's how old GPT-4 is. We are at the very, very early stages here. This thing is getting better. And so another reason is the people who built them, this is both scary and kind of whoa, who don't understand how they do what they do. This is a real criticism. You can't explain how they came to this decision. Now you could ask it actually, and it's pretty good. It can break down an answer into multiple steps that led you to it. How it got those steps, we don't know. But how do you know how you got those steps in your own brain? That's the thing. Apply the questions you're asking it to yourself. You know, we criticize the self-driving cars for causing some accident. You gotta compare it to what people are doing. You need a frame of reference. And I would say to you, the final thing is, I do think that there is a phase shift, get back, that can occur at scale. At different scales, something different occurs. And it's the complexity this is Arthur C. Clarke. He wrote 2001: A Space Odyssey. And I love this quote. Any sufficiently advanced technology is indistinguishable from magic. Okay, what's that? Water. Perfect, right? A molecule of water, H2O. Is it wet? Is it cold? Does it flow? No, no, no. Yes, yes, yes. Okay, so what's going on here? What's going on here is the phenomenon of emergence. This is the most powerful concept in complex systems, where you've got lots of little parts with all connections. New attributes arise at different scales. And it's a core feature of all sufficiently complex systems that the whole, we say, is not only greater than the sum of the parts, but it's different from the sum of the parts. New things emerge. And you see it biologically. You know, you've got molecules, you've got organelles, you've got cells, you got organs. Each one, and there's people, there's psychology, there's groups, there are different vocabularies and different phenomena to describe different levels in this at different scales. And so I think because of emergence, we're going to be seeing some things. Now, I'm just going to say one or two more things and then I'll stop. This is homage to Shakespeare. What's in a name? Does anybody like the name artificial intelligence? I'll tell you, John McCarthy, who thought of it, didn't like it, and I don't like it. I think it's because there's really nothing artificial about what is being generated by AI. So here's some nominations for possibilities. Assistive intelligence, augmented intelligence, those are the ones where they're helping us do better. They're working in partnership with us. Alien intelligence seeming to come out of stuff. We don't know how it's getting what it's getting. Then I like the CI ones, collaborative intelligence, and my favorite actually is computational intelligence. This is intelligence coming out of computation, complex computations. is producing intelligence. Now, you could, yeah, at some point, it may be that what's going on up here in your brain is also computational intelligence. But for right now, I'll reserve computational intelligence versus organic or biologically based intelligence. And I think those should be the two categories. And we should be calling this computational intelligence, or CI. I'm a lone voice on this. This is my own opinion. And we know we have to keep humans in the center, keeping humans in the loop. Human-centered AI. A colleague of mine wrote a book on it. Ben Schneiderman, really good book. Final thing, it's hard, the last mile problem. It's a problem from telecom and transport. Getting stuff into the home. You got all these big distribution centers. How do you get the package delivered to the home? How do you get when we had landlines, the lines into the home? And in AI, the last mile problem is integrating into the existing software and meshing with existing enterprise workflow. I'm glad that Cerner is building it in, but we're going to have to change our workflow, which is very, very hard. And that's often where the dilemma is. It's always harder, takes longer, and you got to make sure the effort's worth the squeeze. I'm going to stop now. I got a couple more things I could say, but I just hope that you have, I've kind of given you a large enough view on this that you will realize this is some amazing technology. It's your generation that are going to be the stewards of this. The future is in your hands. You're going to have to deal with climate. You're going to have to deal with problems with truth and the political problems, and you're going to have to deal with AI. It's a major responsibility, but if you don't do it, no one else will. So thank you. Much appreciated your attention, and happy to take questions.